So in this video, I'm just going to talk about the conceptual ideas of the buffer overrun assignment. I cannot show a lot of code in here because it's a fairly a simple assignment once you figure out the tricks of the assignment. So it's all about understanding what's underneath and how you can impact them. So you're understanding bits and byte level stuff, and you're understanding how to manipulate return addresses and so on. So that's the goal. So you're given this program called unsafe code. This is unsafe code, this great program, which has a function called readString. ReadString has a buffer called buff, which is of size 48. And one of the problems with this code is that it's not checking the limits of the buffer size. So you have fgetC until it gets end of file or new line. So you can keep writing stuff. So this is the allocated 48 bytes, but you can keep writing and eventually overwrite the return address of this function. Because as you know, once this function is called, the return address, which is the next instruction after this in the main, will be stored somewhere here before it allocate memory for the buffer. So it's going to be somewhere here. So your goal is to figure out where that buffer address is going to be. So how do we figure that out? So this is an idea of the stack frame. Suppose you have a stack frame that contains a bunch of stuff. This is the top of the stack right now. Maybe this is the old one, but here's the saved RIP, which is the return instruction pointer here. So this means that once this stack is used, that means when you're returning from this function, you have to return to this address. So what we're going to do is that when you return from a function, what the function is going to do is to load this address into RIP. So RIP is going to execute that address, what the content of that address. So our goal is to really understand how to do it. So your assignment is to really take a given grader program. So you can do GDB grader, and you can start to disassemble that program looking at here 64 lines of code. So it'll produce something like this. So you can see the instructions and their beginning addresses and so on. So you can see where the readString program is and what it's trying to do, and you can figure out exactly how to attack this program. You don't have the source code, so you won't be able to walk through this, but you'll be able to understand how to attack the program. So what's the first attack? The first attack is to get the program to crash. In other words, we got to write a program that's going to put some stuff into this return address. We're going to corrupt this return address. So how do we corrupt a return address? Because we have this program called the read string. Read string takes some input. So in the input, so our program is going to create an input file where we will figure out exactly which bytes are going to be the return address mapping bytes. So in other words, the return address, it's when the program reads your code, your file, it's going to put these numbers into here. So if you can put 000 into that, you're going to crash the program. So the goal is to write a program called create.data.c that can write a binary file called datac that have sufficient characters. You don't want it to be too big to crash the program. Now, once you figure out how to write this binary file, which I will show you in a little minute, you can do hex dump to see -c data a plus to see, or data c to see what are the bytes in the file. So maybe you better see that the last 8 bytes are probably, or the bytes matching to this location are the all zeros, so you can get the program to crash. The second part is the part B, which is obtain a B grade. So if you want to obtain a B grade, what you need to do is we got to put to the return address. So after you do the read string, you read string here. After you read string, you're going to jump to this if statement, but we want to skip that. So we got to figure out what's the address of this grade equals B assignment statement is, but which you can find from this. Okay, you will be able to know exactly where it is, and it's going to remain the same throughout the program. So you find out where the grade equals B is, and you can find that return address by doing GDB grade and all that. And then again, you create a file so that this address is going to be encoded into this file here. So in other words, when you're reading it, it's going to read, it reads the buffer, and then return address, it's going to be here. It's going to jump here, and it's just going to print the grade B. And conceptually, this is what it looks like. So you have grade name. Grade is in the data section, name is in the BSS section, and the name is a global array, grade is a global variable, and your code is somewhere in the text section. Grade equals B instruction is somewhere here. Stack is created by the readString function, so you want to write something here plus something more. And for the return address, we encode this with the instruction of this address. We don't really touch any of these things. What's going to happen is that when the read string is done, this is going to be copied to here. That's the second loop of the read string. But then it figure out returning means going here. So nothing really matters whatever you did here. It will take the name. Obviously, it's going to print the name, and then it's going to print the grade B. Now, when you do the A attack, it's a bit more complicated. So in this case, what you like to do is you're returning from here to this address. So you got to figure out, okay, where do I start here? Maybe I'll start from this address to maybe I put 8 characters here. Then I will start my instruction. So my instructions are not all the same size. So that's something you need to really to know. If you do something like uh, 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 you can actually look at the size of the instruction. We'll show it to you in code soon. So the goal here is that conceptually what you need to do is you take the return address here, say this address is going to be the instruction, beginning of the instruction of move. What that's going to do is to move A into grade. So you have to encode that instruction in machine language, move the character A into the location where the grade is. And then do a jump. Now in the jump, you're going to do a relative jump. Relative jump means that once you execute jump instruction, you are here, this location here. And then you want to go here. So you want to find the difference between this and that. So jump only takes the relative distance. You jump 80 bytes. So it'll go 80 bytes from there. And we can say jump minus 80. It'll go from this place to up minus 80 and so on. So that's what you got to figure out. So those are the techniques that you have to do. And I'll show you how to get some machine code for this, machine code for that, and so on. All right, so next, let's take a look at how we create the data files. We have to create data C, data B, and data A, and data A plus. So here's a demo program that I did create. So this is, again, to demonstrate how to create binary data files. So I have a PS file, which is a file pointer, and I have some address, which is a hexadecimal address. I have encoded it here. I open the file. Then what I do is I write the characters GUNA into the file. Then I write the characters, like null characters, 4 times. And then I put, there are a few things that you probably should understand. argv of 1 is the name of the file, because I'm going to create a bunch of files here with different sizes and see which one's going to crash my program. So we have argv of 2 is going to be the dummy characters, because I'm going to write 8 characters here, and I'm going to write 8 characters here because it's going to take this address and store this as an 8-character thing. So let's do that. So we have 16 characters already, and then this argv2 is going to be a string, and I'm going to do A to I means ASCII to integer, so it's going to convert that to a number. So for example, if I want, say, 32 bytes, I already have 16 bytes, 8 here, 8 here. So I'm going to write 8 more bytes here. So I just have to type in the name of the file and the file here, right? All right, so let's see how this works. So obviously I created a executable from this one called create data. And so if I want to create data, then I can do create data. And then first argument is the name of the file. So let's say I want to create a file with 32 bytes of data. And I already have 16, so I'm going to give 16 dummy bytes. And now I created that data file, which is here, data 32. Now I want to know with the how the data 32 looks like, so I can just do something like hex dump dash C data 32. So it shows you the format of the data. This is very, very helpful. Perhaps this is the encoding of GUNA in ASCII, and this seems like the encoding of this address. Notice that the lower byte of the address 2D comes first, and that's automatically done. You could have done that manually as well. I could have put 2D, put C 2D as an hexadecimal byte, then 0E, the second byte, and the third byte. But notice that if this is a valid address, it will read the address from left to right, and it would transition into that line. For example, as we discussed before, if this is going to map to the return address, so suppose this file has 16 bytes, so we know that this 8 bytes is the return address, then we can just put the return address there. Now the question is, how do we find these return addresses? Where are these return addresses? For example, I can say, so I have a demo program here, I think. Yeah, demo program. So let me take a look at GDB demo, just like you'd say GDB created. Then I'm going to say x64i. This also has a read string. So let's see what I can find out. So here shows you the read string thing, and then where the main starts, what address the main starts, and if I press enter, it'll go down further. Like for example, if I want to jump into say for example here, what I need to do is I need to take this address and encode it into that. So this way, once I'm done with the read string function, it would jump to a specific print statement. So that's one of the things you could do. So, um, and the other thing that you need to do is to look at we looked at the hex dump, but you can also look at the object dump of, let's say, object dump S, and I have this executable called demo. Now, if I do this, then it'll show you the object dump of my demo file. Now, it's going to, in some cases, it may be a very long file because I didn't really build this as a static thing. But one of the things you could do is if you want to have a handle over this one, this seems to be very, very long. So let's just maybe okay, that's what it is. So one of the things you could do is that you can look at one page at a time. So I'm just going to say object dump more. And so I'll see one page at a time. I press enter, press spacebar, it'll go to the next thing and next thing and next thing. And then you can probably find the main program somewhere here. These are all the libraries and other things you need. You could probably find the code for the main. So there's a start here, frame dummy again. Here's the main. So the main program for my program is given here. So one of the most important things that you need to know is that, remember in the B attack or A attack, we have to know what the move instruction is like. So each instruction has its own number of bytes. Like for example, this call queue instruction has these many bytes here. The move instruction has this byte here, move instruction, right? Move into ADI. So we can get the bytecode for an instruction using this kind of object dump. So that's very, very helpful. So let's talk about some of the debugging. So let's take a look at how to crash a program. So for example, this is my demo program, just pretty similar to what we have. So we have a read string function, then obviously this buffer overflows, then it'll have an impact on the return address, perhaps. So the question is, how do I find out how to break the program? So suppose I'm going to run. First of all, let me take a look at let me do a hex dump on xempty on data 24. This has 24 bytes. So this is my hex dump file. So we have a bunch of 0000 here. So if you feed into the demo program, notice the demo program is trying to read some string, data 24, so 24 bytes, it seems to run okay. It seems to print out these things. Nothing seems to matter. If you print out, let's say if you look at data 32, so let's do hex dump of data 32. Now in this case, I have some weird number here. This is supposed to jump into something in this code. And if I run my code with that, so if I say data 32, notice that it does something really weird. It just prints statement 1, statement 2, print statement 2 again, and statement 1 and statement 2, and then this seg false. I think you should be able to describe this behavior just by looking at this file and analyzing this code. And that's kind of analysis that you should be able to do. So when it's seg false, you can also look at where it's seg false. Like for example, if you say GDB a demo, and if you say run with data 32, so it says it receives a signal at that address. So if you just type where, it's going to show you where this thing crashed. So that can give you some idea about, from your memory map, it can give you an idea about where these things are crashing, where is it going, and so on. So that's the kind of debugging that you have to do to figure out how we're going to do this. Right. So the next we will take a look at the opcodes for other things that we are supposed to be doing. So finally, let's take a look at when composing the A attack, we might be helpful. You're given this nonsense.s program. If you compile it and create an executable, all it does is something really simple. So you should be able to see what this instruction looks like and what this instruction looks like. You're jumping to some label here and see how we can make that jump. Notice that the jump is more than 128, so it cannot be encoded with 1 byte, so it'll be a long jump that we have to do. So what are the things that are really important for you to look at? Like for example here, I think what you can do is to go to the debug mode and then type, say you want to look at 70 lines of this code, disassemble. So I created the nonsense file. I think I'm starting from here. So 7 lines that code, right? So we want to look at that from here actually. So we have the move instructions. So this should make it clear that you're moving the character, which is 41, to some address, which is the address of C character in this case. So you need an instruction like this to go into your file, your data file. And so the question is, how do we know the machine code for this instruction? Now, that you can do by doing object dump. So if you do an object dump, you'll be able to see the machine code for an instruction like this. It's right here. So you have to encode these bytes into your file, the data A file, to make it work. So this has like 7 bytes, I think, that instruction. And the next one is the jump queue to some address, future address here. So your jump address actually begins at E9, this F8, and then the next one would be, so you know how much to jump, right? So you have taken these 5 bytes and you want to jump a certain amount. So this is jumping to 57D, which is essentially, if you go look at it, I think 57D is somewhere here. That's the end of the program. That's the end of the program here, move instruction. So the question is, what's the distance between this byte here, or the address here, and where you actually started the jump assignment? Now, if you look at the opcode or the machine code for this one, it's given here. So here's the machine code for the that jump, right? So you should take a look at how this relates to what's given here. What's the jump required? To jump the distance, jump queue. It's a long jump, right? So that's we want to know how that relates. So those are the details I'll leave to you to figure out. So I think these two things are really important. Again, going back to the A attack, the move instruction and jump instruction goes here. That's what you're looking to do. Good luck with the assignment.